We've been asked to determine if f of x is continuous and differentiable at x equals 0. And so we've got two portions of differentiability: continuity, meaning the graphs connect, and then we've got smoothness, meaning the slopes match at a particular point. So we're going to first check continuity by plugging in 0. The square root of 1 minus 0 equals 1. Is that equal to 0 squared plus 0 plus 1? Yes. So we've met the first part of the continuity definition. The y values on each side match. For smoothness, we need to take the derivative on both sides. And so in this first left side, we have u equals 1 minus x squared, and v equals the square root of u. This is a chain rule problem. So the derivative of u prime, is negative 2x. The derivative of the square root of u will be 1 over 2 square root of u, but u was 1 minus x squared. And we know the chain rule says u prime times v prime, so we're going to multiply negative 2x times 1 over 2 the square root of 1 minus x squared. Well, because we're looking at x equals 0, this turns out to be easy. It's 0 times 1 over 2 the square root of 1. Well, that's just 0. And on the other side, when we take the derivative of x squared, we get 2x plus 1. And when I plug 0 in here, I get 0 plus 1. Well, 0 is not equal to 1. So we would say this is not differentiable because the smoothness portion of the definition doesn't work. Now I've asked you to check all of your answers on Desmos. So I'm going to move over to Desmos. So I put the first piecewise portion of the definition. Now I'll put the next, 2x squared plus x plus 1. And we don't want the entire graph. We want the graph greater than 0. So I will put the little squiggly brackets, x greater than 0. Close my brackets out. And now you can hopefully see that there is a cusp right here. And if we zoom in, you can definitely see the cusp. It is not smooth where those functions come together. You were asked also to try to make it differentiable. So we're going to go back and look at the original equation. When I take the derivative of x squared, I'm going to get 2x. And when I take the derivative of x, I'm going to get 1. And this 1 is the problem. So to fix this problem, I'm just going to remove the plus x. And I'm going to say, hey, this was really x squared plus 1. Now when I take the derivative, I'll get 2x plus 0. And when I plug 0 in, I'll get 0. And I'll go back to Desmos and check myself. What if this x were gone? Now hopefully you can see that the slopes do match left and right. And even if you zoom in, it's 0 coming in from both sides.